In this video we're going to graph some exponential equations, exponential functions. So before we get into that, let's be real clear what makes something an exponential function. An exponential function is going to be in the form f of x equals, this is a basic one, a to the x power. So what makes it an exponential function is the variable is in the exponent. That's what makes it an exponential function. A couple little restrictions you want to be aware of is that a, the number that's taken to the variable power, has to be a positive number, greater than 0. We don't want to look at taking negative numbers to a power, because if the power is 1/2, then that means we're dealing with square roots and we get numbers that aren't defined and all kinds of stuff we don't want. So a is greater than 0. We also don't want a to be 1. If a is 1, then any number we put in for x, 1 to any power, is just going to be 1. So we end up getting just a line, a horizontal line, and that's not what we want either. That doesn't really classify as an exponential function. And as far as x goes, x can be any real numbers, and this notation means x is an element of the real numbers. So x can be anything. A, we want that to be positive, but not 1. So let's go ahead and look at our first example that we're going to graph. And we're going to start with a basic equation here, which is f of x equals 2 to the x. And we're going to go ahead and graph this by doing a table of values. We're going to do some positive values and some negative values. So let's go 3, 2, 1, 0, -1, -2, -3, and see what happens. We're going to take this x value and plug it in up here for x. X equals 3 would give us 2 to the third power, which is 8. So our first point is 3, 8. Let's go ahead and graph these as we do them. Over 3 up 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's our first point. Next point, x is 2. We're going to put 2 in for x. 2 to the second power, that would be 4. So x is 2, y is 4. 1, 2, 1, 2, 3, 4. Next point, x is 1. 2 to the first power, obviously that's 2. For this point then, x is 1, y is 2. We're going to go over 1 up 2, make a point. Starting to see a little bit of a pattern here. Notice these are not in a line. Next one, 0, 2 to the 0 power. Anything to the 0 power, these are supposed to be little arrows here, is 1. That gives us the point 0, 1 on our graph. Starting to curve now. See that? Starting to curve. Let's see what happens. -1. Now this is where we need to be good at our rules of exponents. 2 to the -1. What does that mean? Just a little review. Negative exponents do not mean negative numbers. Negative exponents mean reciprocal. So this is basically the reciprocal of 2 to the first, or 1 over 2 to the first, which is 1/2. Okay, that gives us the point -1, 1/2. So we got to go over 1, -1, up 1/2. We're just going to kind of estimate that right there. Next one, 2 to the -2. Negative exponent means reciprocal. So this means the reciprocal of 2 to the second, which is 1/4. -2 up 1/4. That's just barely up right there. Next one, 2 to the -3 would be 1 over 2 to the third, or 1/8, barely up. -3, 1/8. Now it's not touching the line, but it's getting really super close to the x-axis here. And hopefully you see, if we keep going, if we did -4, it would be 1 over 2 to the fourth, or 1/16, which is just going to be even closer to the line, but still not touching it. And then it'd be 1/32 and 1/64 and 1 over 128. It's going to get teeny, teeny, tiny, but it's never, ever going to touch that x-axis. So let's see, we could draw it like this. And by the way, if we did 4, x is 4, that would give us 16, which is off my chart here. So it really shoots up, and then it comes down. Try to draw this as best I can and get all these points and not touch the, it looks like all right, it's going to look something like that. All right, that is the graph of f of x equals 2 to the x power. Or just for fun, let's talk about the domain and range. I wasn't going to do that, but what the heck. It's always fun to talk about domain and range. Especially when you have the graph, it makes it a little bit easier. So the domain, all the x values here, how far to the right does it go? How far to the left does it go? It goes forever in both directions. So the domain is all real numbers. You could write that in interval notation like this, or just all real numbers. The range is the y values. How far up and down does it go? Well, this is where we have a little restriction here because it's not going to get any lower than 0. As a matter of fact, it's never going to touch 0. It's always going to be approaching 0 but never touch it. So we would want to say that in interval notation with a parenthesis, 0 all the way up to infinity. My infinities kind of look like 8, so I should draw them a little more like that. There we go. So that would be your range. Another way to say the range would be y is greater than 0, or set of all y such that y is greater than 0. Some people use the 2 dots for such that, something like that. Okay, so there's your domain and range. There's our first example of an exponential equation. All right, let's see if we can do another one here real quick. Let's get rid of all this. And let's do f of x equals 1/2 to the x. Now if you want to try to do this one on your own, maybe pause it and then try to fill in this chart all on your own. Let's do the same numbers. Let's do 3, 2, 1, 0, -1, -2, -3. Pause it, do it on your own, and then check it. That's a great way to practice math. Alright, so here we go. Let's go through this. We got 1/2 to the 3rd power, which is 1/8. 1/2 to the 2nd power, which is 1/4. I didn't leave myself enough room here, did I? 1/2 to the 1st power, which is 1/2. 1/2 to the 0 power, which is 1. 1/2 to the -1. Okay, remember this means reciprocal. So I'm going to flip the 1/2, that turns it into a 2, and then take it to the 1st power, which is just 2. 1/2 to the -2. So the negative tells me to flip it, the 2 tells me to square it. Flip it and square it. Flip it is 2, square it is 4. 1/2 to the -3, flip it is 2, cube it is 8. So these numbers look really familiar, don't they? They should, because they're the same numbers we got last time, except they are paired up with different values of x. So let's take a look and see how that affects our graph. Let's plot these points. Okay, we've got 3 and over 3 up an 1/8, just barely up right there. Over 2 up a 1/4, over 1 up a 1/2, over 0 up 1, -1 up 2, -2 up 4, -3 up 8. So you can see it's the same exact shape we had for 2 to the x, except it's reflection. Oh, that's not the best drawing I've ever done. Okay, if I had time I'd do that better, but you get the idea. It's a reflection over the y-axis here. But it's the same kind of pattern. So hopefully you see these exponential problems in exponential form or exponential functions. They're always going to have this kind of a shape to them. They're going to approach something, and then they're going to shoot up and get really big get large very quickly in one direction. The domain and range of this would be the same as the domain and range of the other one we did. You'd have all real numbers for your domain, and your range is still everything bigger than 0. So hopefully that helps and gives you a little bit of confidence when you're graphing an exponential function.